Hello dear students, are you preparing for NEET, JEE or KCET? Looking for the right guidance to achieve your dream rank? Welcome to Global Academy live coaching classes for NEET, JEE and KCET. A single point and complete solution for competitive exam preparation. Specially designed for 11th, 12th, 1st and 2nd PUC students. Combining board syllabus with a entrance exam preparation. New batches are starting from 25th March 2026 for the academic year 2026-27. Fee structure rupees 9,999, 50% discount of 4,999 for the entire course. Call these numbers for further enquiry. Scan QR code for easy payment. Hello dear students. Welcome to Global Academy. I am Dr. Vinayak, your physics educator. So today we will discuss about the unit 1 of 12th class or 2nd PUC. So that is electric charges and fields. The topics to be covered in this class are electric charge, conductors and insulators, basic properties of electric charges, Coulomb's law, and force between the multiple charges. Okay, so in our daily life, we will come across with a certain phenomena like when you rub your dry hair with a comb, so and bring the comb towards the pieces of the paper, so it is going to attract. Or during the winter season, usually when we are removing the nylon clothes, so your hairs it becomes straight, or you are getting the goosebumps, right? So these are the examples for what? The charges or charged bodies. So now let us see how these charges are created. So when you rub the different materials like the glass rod, when it is rubbed with a silk cloth, or when you rub the cat skin with the ebonite rod, or when you rub the woolen cloth with the amber rod, so or woolen coat with a plastic seat, or woolen carpet with a rubber shoes, you will get the charge bodies. Means the rubbing is the one of the phenomena which will create the charges. So when you consider the rubber glass rod, so here when you take a glass rod, when you rub with a silk cloth, so at that time glass rod surface is get the positive charges and silk cloth is get the negative charges. Okay, so these are the phenomena which was observed by the scientists. Similarly, when you rub the ebonite rod with the cat skin or the cat fur is get the positive charges and ebonite rod gets the negative charges. Similarly, woolen cloth is get the positive charge. When you are rubbing with the amber rod gets the negative charges. So similarly, so see here, I will take the example of the glass rod and the plastic seat or plastic rod. Okay, when you take the plastic rod, when it is rubbed with a woolen coat, so the plastic rod gets the negative charges. When you rub the glass rod with a silk cloth, glass rod gets the positive charges. The scientists performed the experiment that so the positively charged glass rod brought towards the another positively charged glass rod, that they are observed that they are going far away from each other. So you can see from this figure, right? So the two positively charged glass rods are going away from each other. So in the second case, see here, this is the negatively charged plastic rod. So here one more negatively charged plastic rod you are having when they are bring towards each other. So here also you can see the same phenomena, that the two negatively charged plastic rods are goes far away from each other. So however, when you bring the positively charged glass rod towards the negatively charged plastic rod, so that is the third case, so they are come closer to each other. From this observation, the scientists come to the conclusion that when you are bringing the two like charges, like in the sense it may be positive and positive. If you bring the two positive charges, or if you are bring the two negative charges or charged bodies close to each other, they are repels each other. However, when you are bringing the two unlike charges, that is positive and negative, they are attracts each other. So that is the overall conclusion from this experiment. So now let us discuss about what are meant by conductors and insulators. Conductors are those materials which are causes the ease for the flow of electricity. However, the insulators are those materials which resist the flow of electricity. Now let us look at the definition. Conductors are the materials which allows the electricity are called conductors. For example, so silver, copper, iron, almost all metals are the example for the conductors. So silver is the good conductor. Okay, so it is conducting very high electricity through it. However, if you are considering the human body, that is also a good conductor of electricity. So in case of the insulator, if you are considering, which will resist the flow of the electricity, right? Insulators are those materials which resist the flow of the current. So the example for the insulators are glass, rubber, or if you are considering the plastic, all these are the example for the insulators. Now let us discuss about the basic property of the charges. Okay, when you are considering the examples in this tabular column, so here you have observed some bodies are get charged by rubbing, right? So here the glass rod is positively charged, we are telling. The plastic rod, we are telling it is negatively charged. So now let us discuss about what are the properties of these charges. First one is charges are additive in nature, or additivity of the charges. For example, if you are considering the glass rod, when it is rubbed with a silk cloth, suppose this is the silk cloth and this is the glass rod. So glass rod get positively charged and silk gets negatively charged. Okay, when I am writing so here what are the total charge on the glass? So at that time I have to count it 1, 2, 3, 4, 5. So means there are the total 5 plus charges on the glass rod. So and when you are considering the charges on the silk, here also I have to add 1, 2, 3, 4, 5. So there is minus 5 charges on the silk rod. So that is when you are considering the total charge of the whole body, that is the sum of individual charges in that body. Okay, so next, that's what we are calling as the property of additivity. Additivity means what? Addition or summation of the all charges or constituent charges in that body. Next, the conservation of charges. What is meant by conservation of the charges? It is similar to the law of conservation of energy. According to law of conservation of energy, you can neither create neither create a energy or not destroy the energy, but you will transform one form of energy to another form of energy, right? Similarly, the conservation of charges will tell you can neither create the charge or not destroy the charge. The total charge of the system is always conserved. For example, here when we are considering the charging of the two bodies by rubbing, so before when we are rubbing the glass rod and silk rod, so it was not charged, right? The silk cloth and glass rod is not charged, means the total charge of the glass rod is 0 and total charge on the silk is also 0. So when you are taking the total system, the sum of the charge of whole system is 0 plus 0 is 0. Okay, when you are considering the charged body, so after rubbing, so here the glass gets plus 5 charges and silk gets minus 5 charges, means these charges are arise because of transfer. Okay, when it is gets plus 5, the another body which is get minus 5. If you are adding these two things, then you will get the total charge of the system is 0 only. Okay, so therefore here you are not creating the charges, but you are transferring the charges from one body to another body, such a way that the total charge of the whole system is always conserved. Okay, so next, here when we are considering, so we are representing the charge of the body is plus 5, right? What is the SI unit of this charge? SI unit of the charge is coulomb. Okay, so coulomb is the SI unit of the charge, which is represented by capital C. So here plus 5C or minus 5C. So like this we will represent. So that is the SI unit of the charge. Now let us look at the quantization of the charges. So when you are considering the quantization of the charges, so here quantization means multiple amounts. Okay. So when you are considering the total charge on the whole body, that is a multiple of one elementary charge, that is plus E or E. So the elementary charge is represented by the symbol E, and its value is 1.602 into 10 to the power minus 19 coulomb. Okay, so this is the elementary charge. When you are considering the total charge of the body, it is always in the multiples of this one. So therefore, suppose if I consider the total charge of one rod is a capital Q, so it is always the multiple of n times E. Okay, so that is the quantization. Quantization means what? So when you are considering the overall charge of the body, it is always comes in the multiples of E. That is, it may be 1E or it may be 2E or 3E, like this. Suppose if you are considering the charge on the another cloth, so here when you are considering the charge on the glass rod, so suppose it may be Q, so that is Ne. So the charge on the another cloth, it may be Q dash. So Q dash may be again N dash into E. So here E value is always fixed, that is 1.602 into 10 to the power minus 19 coulombs. So these are the basic properties of the charges. So now let us look at when you are bringing the two charges. So that is, when you are bringing the two like charges, it is going to apply the force on each other, right? If you are bringing the two unlike charges also, it will also apply the force on each other. What is the force of interaction between the two charges was given by the Coulomb, so which is known as Coulomb's law. So what the Coulomb law states? Coulomb law states the force of interaction between the two charges. It may be a like charges or unlike charges. When you are bringing the two like charges like positive Q and minus Q, if you are bringing, so these are the example for the unlike charges, it is going to attract each other. So if you are bringing the like charges plus Q and plus Q or minus Q and minus Q, so it will repel each other. Like the magnets for a like poles, when you are bringing the two like poles, it will going to repel each other, that is north and north poles or south and south poles. If you are bringing towards each other, it is going to repel each other, right? So however, if you bring the positive pole north pole and the south pole towards each other, so at that time it is going to attract. Similarly here also, the two like charges are going to repel and two unlike charges are going to attract. Okay, so now let us discuss what the Coulomb law states. Coulomb law states the force of interaction between the two charges. Let us assume you are having the two charges, one is Q1 and another one is Q2, which are separated by a distance of r. So then the force of interaction or the magnitude of force of interaction is given by the Coulomb's law. That is, the force of interaction is represented by F. So this is directly proportional to the product of the charges. So the product of the charges, in the sense, here the product of magnitude of charge is what? Q1 and Q2. So therefore, from the first part, we can say F is directly proportional to Q1 and Q2. Okay. So from the second part, this is it is the continuation of the Coulomb law, that is the force between the two charges is inversely proportional to the square of the distance between them. So here I have considered the square of the distance between the two charges is r, right? So according to the second part, we will get f is inversely proportional to the square means r square, right? So when you combine these two things, that is f is directly proportional to q1 q2 from first part, and f is inversely proportional to r square, that is 1 by r square. So if you combine these two things, you will get f is directly proportional to q1 q2 divided by r square. Okay, so now to remove this proportionality, I will introduce one constant of proportionality k. So that is f is equal to k q1 q2 divided by r square. So now this k is given by 1 divided by 4 pi epsilon naught, where epsilon naught is the absolute permittivity of free space, and the overall value of this one is found to be 9 into 10 to the power 9 Newton meter square per coulomb square. So this is the SI unit of the K. Okay. So now to write this law in terms of the vector format, it is necessary to know what is the direction of the vectors. See, here when you are considering the two charges q1, here when you are considering the two charges q1 and q2, so suppose, so if you want to find what is the force on the first charge due to the second charge q2, so how we will represent it? So we will represent it in the format that force on the first charge due to the second charge by this format. Okay, so this is the standard Newton's format. So that is represents the force on the first charge due to the second charge, which is equal to, so 1 divided by 4 pi epsilon naught q1 q2 divided by, here which r we have to consider? Here we have to consider the r is also in terms of the vector format, that is also starts from first due to the second charge. So it is in a vector format, so therefore you have to put as a vector symbol over that r square, and its unit vector you have to represent, that is r12 cap. Okay, so similarly here this is what the force on the first charge due to the second charge. Similarly, the second charge is also get affected by the first charge, right? That is force on the second charge due to the first charge is represented by the formula 1 divided by 4 pi epsilon naught q1 q2 divided by r21, that is r21 vector square into r21 cap. So this is the vectorial form of the Coulomb's law. So now let us discuss about the properties of the Coulombic force, that is the force of interaction between the two charges. Okay, according to the Coulomb's force, so here the what is the direction of the force that we have to find, right? So the direction of the force is given by, it is the acting along line joining two charges. Suppose if you are considering the two charges, suppose if you are considering the two charges q1 and q2, the force acting between the two charges is given by, so it is acting along the line joining the two charges. So that is the meaning of first property. So second one is conservative forces. So this obeys the total sum of the kinetic energy plus potential energy is always constant. So that is the property of conservative forces. So next one is, so the force of interaction between the two charges is depends on the which kind of medium you kept the charges. So suppose if you are keeping the charges in the air, the force of interaction is different. If you keep this whole charges in the water medium, so then the force of interaction between the two charges will be different. Okay, so therefore the force of interaction between the two charges is purely depends on which kind of medium you have kept the charges. Okay, so next, the force of interaction between the two charges is obeys the inverse square law. Inverse square law states that so if you increase the distance, then the force is reduced. So that is the force is reduced by an amount 1 by r square. Okay, so that is what we are calling as inverse square law. So if you go far away, or if the two charges r goes far away, at that time the force is reduced by the amount 1 by r square. So that is what the meaning of fourth line. So now it is going to obeys the Newton's third law. The force of interaction between the two charges obeys the Newton's third law. What is the Newton's third law? It will states, the Newton's third law states that for every action there will be equal and opposite reaction, right? So that's what I told. So if you are considering the two charges, so suppose if you want to study what is the force on the first charge due to the second charge, so at that time the second charge will not stay silent, right? So the force on the second charge on the first charge is given by F21. So means the first part it will tell, okay, F12 represents what? The force on the first charge due to the second charge. So F21 represents the force on the second charge due to the first charge. So therefore, the first charge is also get affected by second charge. The second charge is get affected by the first charge. So means for every action there will be equal and opposite reaction. Last property it will tell the force of interaction between the two charges so is not affected by any other charges which is present in the medium. For example, if you want to study the force of interaction between the charges q1 and q2, suppose there is a one third charge, so q3 is present. At that time when you are solving this one, so you have to focus only on q1 and q2, not on q3. So that is the force of interaction between the q1 and q2 only we have to consider. Okay, so suppose if you want to study the net resultant force due to all these three charges, for example, what is the net force on the first charge? That is, it is the sum of what? The force on 1 due to 2 and force on 1 due to 3. So that is what the force of interaction due to the multiple charges you will get. So what is the formula for a F12? F12 is given by 1 divided by 4 pi epsilon naught Q1 Q2 divided by R12 whole square into R12 cap. So force on 1 due to third charge is so 1 divided by 4 pi epsilon naught Q1 Q3 divided by R13 cap the whole square into R13 cap. Okay, so this is what we are getting, what? The net force on the first charge. So therefore when we are considering the force on the first charge, so we are individually solving. When we are individually solving here, for example, F12, we consider only two charges, that is Q1 and Q2, not we bother about the Q3 charge, right? That we deal separately. So therefore, when you are considering the interaction of the two charges, we are neglecting the force of interaction due to the any other charges which is present in the medium. So regarding this all properties, so what we discussed today, so regarding, so today we discussed about the electric charges, conductors and insulator, basic property of electric charges, Coulomb's law, and force between the multiple charges. So we will discuss the multiple choice questions on this topic in the next class. Thank you.